So we are technically starting a new topic today, but it's going to be a lot of what we've already been doing, a lot of graphing, but we're talking about what's called systems of equations. So the very first thing I want you to do is to graph the equation y equals x plus 2. And we've been graphing this week, so I know that that equation is starting at a positive 2. That slope would be 1 over 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. I could keep that pattern going, and then we're going to connect all the way across. It says on the same graph negative x plus 8. So I'm going to start at a positive 8. My slope is negative x, which is the same thing as negative 1 over 1, down 1, run 1, down 1, run 1, down 1, run 1. So the biggest difference between the past few days and today is now I'm putting two equations on the same graph. It says, do the lines intersect? Intersect being just a fancy word for cross. Do they cross? Yes, they do. They cross at this point right here. It wants to know where that x number would be 3, that y number would be 5. When I'm telling where they cross, it's super important that my first number is my x number. The x number for that point is 3. My second number is my y number, which is 5. Now we haven't done a ton of talking to say, is this point a solution to the first equation? But there's two ways I can do it. The first way is I can look at the graph. To the equation x plus 2, is 3, 5 on that line? Absolutely, it is. I can look at the graph and see. I can also plug in and check. So in that equation, y equals x plus 2, instead of saying y, I'm going to say 5 because 5 is my y number. 5 is equal, instead of x, I'm going to say 3. 3 plus 2. 3 plus 2 is 5. 5 is equal to 5. That's absolutely true. Looking at my other line, it wants to know, is 3, 5 there? Absolutely. It's on both of my lines. So I can tell by looking at their graph, that's probably the easiest way to tell if something is a solution, but I can also plug it in. So my equation, y equals negative x plus 8. My y number is 5. 5 is equal to negative x, which is 3, plus 8. Negative 3 plus 8. 5 is equal to 5. We're golden. When I'm finding a solution to my equations, an ordered pair is a solution to an equation if it satisfies the equation, which just means that it is on that graphed line. This point right here is a solution because it is on that graphed line. If they gave me a point like right here, this would be not a solution because it's not on my graphed lines. It's completely off. So I'm looking for the point on the lines where they cross. If I don't have a graph, I can also test it by plugging in the x and the y values from whatever ordered pair they gave me to see if it makes the equation true. We plugged it in right here. 5 is equal to 5. Yes, that's true. It works. 5 is equal to 5. Yes, that's true. When we're saying systems of equations, all it means is that I'm having more than one equation with the same variables. In 8th grade, we're only going to deal with two equations that fall on the same graph. the point of the intersection is the ordered pair that satisfies, or the solution. The big part that we need to know from today, not just the graphing, but I'm looking for the point of the intersection. So I have another equation right here. I want you to first tell me what those two equations are. Tell me what the equation of this line and this line is. Y equals, I'm gonna give you a heads up, I'm not gonna write those on here, so you're actually gonna have to count them. I'm gonna come around and check them. You guys have been writing equations for several weeks. My solution, what coordinate do they cross each other at? That's my solution. Make sure that you tell me your, I didn't mean to write that on the line, your X number and your Y number. Okay, tell me the X coordinate where they cross, the Y number where they cross, and then we should be able to come back and plug those in. I'm gonna walk around and check this while you guys work. Go ahead and pause that video now. So my back questions, you guys are gonna do the back questions by yourself. It's doing the same thing. Graphing two equations, telling me where they cross, the X number where they cross, the Y number where they cross, plugging it in and checking. I know so far we have not seen an equation that looks like Y equals 5. I'm gonna go ahead and graph it for you. That line right there is where Y is equal to 5. So you only have to graph this one equation. Tell me where they cross, get your answers, and then plug it in. So on your check, you should have two different checks. Y equals negative 1/2 X plus 3. Plug your answers in, make sure that it works. Y equals 5. Plug your Y answer in and make sure it works. I'm gonna turn you loose. I'm gonna be walking around while you work. Let's get busy.